My name is David Humphrey. I am an analyst with ARC Advisory Group based here in Germany, and I would like to welcome you to our ARC web window of this quarter. Our subject for today is cloud-based software and services, and what that means is we're going to look at the way that services are being changed, modified, modernized, and enhanced by all of the possibilities of cloud-based data. I would like to introduce my colleague, Florian Güldner, Director of Research here at ARC in Europe. Florian is going to start off the presentation, hold most of it, and I'm going to chime in the middle with some information on traditional services. Florian, I pass the baton to you.
Yes, good morning from my side. Welcome and thanks for the introduction, David. Yes, my name is Florian Güldner. I'm a Director of Research / Analyst here with ARC in Munich, and for I think a couple of years now I do follow the market of automation services, and also since a couple of years I'm following the market for cloud-based software and the like. And so we decided to share some of our findings we collected over the last years with you here today. And yes, for this, just kicking it off, I hope the technology works fine. You can actually use the request button, so there is a field where you can ask questions, and these can be in terms of the content, and they can be in terms of the technology, so please do raise your hand, ask questions. We will do the Q&A consolidated at the end. And well, so this is the content of today's presentation. We start with an overview of traditional software. We talk a little bit about the change in software, then David will take over for traditional services, and I'm going to say a few words about the merge. I think we are right now in the once in a lifetime position when we look at the market of software and services, as it is changing fundamentally. It's changing rapidly, and it will only change in this direction once, which does mean two things for us analysts here. First, we are very, very happy because it's very exciting time. And second, no one really knows what is happening in terms of market development and the like. So we do have our own visions, we do have our own models, but it's not the only truth out there. But we'd like to share in this presentation our view of the world in terms of software-based services, cloud-based software. Now, if you look at the real traditional software market, you would actually buy a huge piece of software. You maybe have add-ons, and you typically buy a license for 3 to 4 years or longer. Obviously, these softwares, they can be very, very expensive. So we have seats that cost $20,000 or more. So there are financing models to split out the costs over time. But overall, the traditional software market is still a client-server model. So you install it on the central server, you install it on your PC, and then you have the client sitting in front of it. This is already changing. That's why it's even more yesterday than today. But it is changing today, and there are companies that do already large part of their software business is as a subscription. In the ERP layer, the majority is actually already a subscription. In the automation area, subscription and software as a service-based business is significantly less frequent. Now, this is going to change. Again, no one knows 100% how the future will look like. But there's one concern we get in this tension and in this environment that comes from the production floor. And I just recently read an article from a friend of ours here at ARC who's discussed a lot of technological trends, an end user, and he asked the question, is the ISA 95 still valid? Will it persist in future. And just for everyone to get the head around it very, very briefly, this is the very traditional model. We have the actual production process here at the very ground floor, so to speak, level 0. We have the sensing and production. Here we go to the HMI layer, and then we go up the IXA framework up to business planning and logistics. I mean, everyone knows that I don't want to spend too much time on it. What I want to spend a little bit more time is ARC's collaborative manufacturing model, in short CMM. We do have that sphere which we see represents, let's say, any manufacturing producing company out there. And we have those three axes. One is called operations, from automation, so here you have the sensors and the field devices, up to business, where you have the ERP and the like. We do have the life cycle of the model, of the product, starting at the product design, ending at the support, and we do have the logistics, inbound and outbound logistics. And in this sphere, in this 3D model, you could actually place all kinds of different software pieces, and if you want to put these like pieces and individual software into larger buckets, you basically end up with these categories: business planning, inbound supply chain, obviously we have outbound supply chain as well, plant design, product design, plant operations, which is very much down here, internal collaboration, plant support services, product support services, and customers and order fulfillment. Now, this is the traditional framework, and if you would view it from a slightly different angle, you have the machine here, and then the data here visualized by zeros and one. It basically moves up, and you have the different software pieces. Big commercial softwares, and we know many people still use Excel spreadsheets and Word docs and PDFs as production management. You have different stakeholders along the line, and obviously everyone wants to close the loop. Ideally, you would close the loop all the way down from the ERP level back to the machine design. So this is not really done that frequently, unfortunately. Going back one slide again, this is the CMM. It basically has these various software functions in there, and when we talk to people, to users as well as suppliers, they have one big question looking at software, and this is, will the traditional framework remain valid? So are they able to use this terminology and this way of thinking? Are they able to use it also in future? I would like to encourage everyone to basically get rid of these software acronyms that we have, those three-letter acronyms, and think in terms of questions these software pieces and that individual softwares are answering. So these are questions, and who is doing the job? What's going on in the production? What are my costs? Where is it going to happen? How is my asset doing? How are we going to produce? And you could put much more three-letter acronyms below each of those questions. Long as these questions remain, also the software functions and software pieces need to persist. They will not change. Now, even if you have a 3D printer, you actually need to know how the 3D printer is going, or how it's producing. If it's stuck somewhere, if it has a problem, does it need more plastic infeed and the like? So this all needs to be answered. And it will also need to be answered if you have a world-scale chemical plant or a very module-based pharmaceutical factory. So these questions will remain the same. What really will change is how they will be answered and who they will be answered, who will answer these questions. It can easily be that we have a system of systems where there is the question, where is it going to happen? And there is an optimized automatic planning algorithm that says it will happen in Munich. You will produce in Munich, you will produce in Zurich, you will produce in Boston, wherever. But these fundamental questions we are really convinced these will remain the same. Let's say the first takeaway is you can actually still work with your traditional framework because the questions will remain the same. The question is, what will change then? Well, I spoke to one large software provider, and he literally said you have to go through a rally of tears. If you're going to switch your business model from selling one-time licenses for 3, 4, infinitive years, and you switch to subscription model, this needs to have, well, this will have a transition period. And I have one example here. This is real data. It's one company that announced in Q1 2015 that beginning Q1 2016 it will have subscription-only business. So what happened here, that was the announcement, revenues, that's the blue line here, that's the revenues in millions of dollars, visualized here, and on the right axis you have those columns, green above 0, red below 0, and this is the year-to-year change. So what happened actually, the growth went down. Maybe here you have a last pickup before people think, oh, next year I can buy subscription only, let's purchase as much as I can. And then business dropped. That's 2016, and business dropped here of around 20%. Now, this company is not doing that, not at all. It's a brave step. It's this valley of tears. And if you want to have just a theoretical thinking behind it, it's very easy. If you're first selling 4-year licenses, and suddenly you just sell a subscription, if the subscription in 1 year, you basically have 1/4 of the revenue in the first year. So that it could drop by theoretical 75%. Now this is a theoretical scenario. It's clear, we mentioned before, there are licensings, there are transition periods and the like, so it's not that easy. But this basically shows you what can happen to your revenue stream if you go 100% subscription. Now, how will that look on the technical side? So how will software change? First, business, yes, it's going to hurt. And again, we have here our CMM, our sphere from ARC. We have the individual buckets here on software categories. And just to make it a little bit more confusing, here are all the 3-letter acronyms we could find that basically make up the complete market for software in manufacturing, which is in total, I think, more than $400 billion, adding all these together. Now, we think that in future we have this common database, sometimes referred to as common data bus. So a bus, basically a layer with all the data. It could be an internal server, and most likely it will be cloud-based. But then in future we won't have these very, very big software. What we do have instead are these very small apps. These apps are significantly small, they are cheaper. You can subscribe to them, and instead of buying a huge HMI software or MES software, you just buy those pieces of the MES, those pieces of the PLMs, those pieces of the CAD/CAM design that you actually need. You subscribe to them, and you base everything on common data. Now, these apps, as we have it here, they are, in this case, cloud-based. And so what you still need is the foundation here. You have all the operating systems for the IoT hardware. So these are the PLCs, the intelligent field devices, intelligent sensors, the IPCs. You connect up via a gateway, very fast-growing market right now, so basically collecting data and sending it off on the cloud. You actually have device management. Whatever you need to do up here with your apps, you need to manage the devices, you need to get down to the devices. And you have the apps, the edge analytics, which basically brings the intelligence of the cloud also on the field level. still need the physical storage, you need the data center, and you need a couple of functions that are the same across all these apps. Now, one of the main changes between writing an app and coding a software is that first, it's much smaller, and second, these apps are largely sampled. So sometimes those apps here in the hexagon, the big app, the hexagon here, they have small software pieces. They are sometimes referred to as microservices, sometimes as backing services, which you basically use to make the fundamental programming of your app, and afterwards you still add some hard coding of your actual app that you want to do. But for example, visualization, it will be the same if you want to visualize something for HMI software, something for MES, something for a very specific application like a pump or a tank. There are pieces of the visualization that you can use across all of these. Data analytics, the small piece of the puzzle, very easy example is the fast Fourier transformation that you will use in loads of apps, from visualization to asset analytics. These microservices, those backing services, they are cloud endemic. That means a given platform, being it GE Predix, Siemens MindSphere, Azure, and whatever, they have a certain set of microservices or backing services that are specific to that cloud, which also means that you cannot really export and import those apps from one platform to another. Right, there are movements going on like the Cloud Foundry that want to have that more standardized, so you can export and import those apps, but I don't want to get that far into it. Now, if you think of the doing business with apps, there's a fundamental difference also with the coding part. And if you think how big Microsoft Windows is and how small amount of companies is out there that were doing operating systems in the 70s, 80s, 90s, and how many app companies are out there now. So it's much easier to sell apps or to program apps, to put apps out there, than it is to put huge softwares out there. This also means it's easier, there are more diverse companies, and the business model is also different. So actually, for example, for a machine builder, it may be actually a very good business to put remote monitoring out there for free. Why? Because he can access the data and build better machines. He can close the loop. You can still have a business model like one-time payment, very traditional, subscription, which is, and consumption-based, which is currently the most popular one. Subscription means you basically have a flat fee each month. Consumption-based means that you have a fixed scope, for example, a certain task for asset analytics, but you then pay based on costs. You pay based on the megabytes, gigabytes that you use in the cloud, or the data points you connect. And really up to pay-per-use and consumption, this is all still a cost-based business model. Pay-per-use is consumption-based, so you pay more if you use more of the resources, but you can also scale up in scope. So in addition, you could basically conference in experts, you can conference in support, and basically increase the scope of your service. So we are really saying now the app is purchased as a service, not just software anymore. And the last two are really value add. They're very interesting for OEMs, where they guarantee uptime or they guarantee throughput. This is already in use, for example, from Kaiser compressors. They make a big announcement, I think, 1 or 2 years ago. So business with apps is fundamentally different from making business with huge pieces of software. Now, there are challenges and there are benefits. Let's start with the challenges. Again, I said it already. There are much more new players. If you can assemble an app very, very quickly, it won't just only be the big software companies that are out there today, but also OEMs will be part of that. Third-party service companies will be part of that. And so many, many new companies coming in there. Creating a value proposition is actually becoming tougher, because if you do have the transparency and everything, it increases the competition and users are only willing to pay for what creates value. The monetization is obviously hard if you have companies out there doing the job for free, like remote monitoring of a machine. If you have that for free, it's harder for other companies to charge money for that. You need a large amount of trust in this kind of business, because you don't have a black box anymore. It's becoming really transparent, and you need to open up. Cybersecurity, of course, that needs to be guaranteed across everything. If you look at the next point, it's the split between risks and benefits. And just looking at the business model, here, if you have consumption-based, then if you don't consume, for example, a software, if you don't consume the software as services, if you don't produce data that has to be stored in the cloud, then the revenue goes back to zero for the software vendor. Also, the costs go back to zero for the users. But this means in this case, the risks actually shift from the user to the vendor. This also means assuring cash flow for vendors can be difficult, and you may have less loyal customers because you don't need a very big software, but a couple of those small apps, the user may just choose the cheapest available on the market, as long as it is available on a given cloud platform. The good thing is we have very low barriers to entry, so you could try a lot of new things. You could offer loads of apps without having that high sunk costs. You can scale up step by step. So the free version is actually a good way to just get started and monetize later. We have a better match of supply and demand. We have these apps are affordable for all, so very small companies. Again, you can reduce the risk, you can share the risk, and you have those breathing scope of software and services that in downtimes and uptimes both can be adjusted. So much to doing business with apps and how it differs from traditional software. And David, I would like to pass on to you now.
All right, thanks, Florian. I'm going to take a step back and just remind the audience of how traditional services, including services with modern technology, are handled today. The traditional services for automation equipment and also for machinery tend to focus on replacing spare parts or managing spare parts, maintaining automation equipment or maintaining single machines, maintaining entire processes in plants. They also involve doing projects like small retrofits to existing machinery, modernizing existing machinery, or modernizing existing automation systems. We call that a migration to a more modern system. Most of the services conducted today are still driven by cost pretty much. In other words, we wait for a problem to occur. We go in and fix the problem, charged by the hour. We often simply correct problems that have occurred. In other words, we don't look very far forward to try to prevent problems from occurring based on indicators. And we often conduct services within cycles. We say that we'll provide services with a contract for the next year or for the next production season. Let's go to the next slide and look at some of the trends. Again, we're still talking about traditional services. In the past decade or so, we've seen a lot more services where providers of services are third parties and offer models such as performance-based contracting. Performance-based contracting for services tends to be based less on output and more on factors like maintaining uptime. In other words, my job as the third-party service provider is to ensure that the machinery is always available, availability as close to 100% as possible. If I can guarantee that to the customer, then the customer can make sure that his machines are performing and producing at a high rate as possible. Outsourcing has also become more popular in the past 10 or 20 years. Outsourcing simply means that we're taking services that were previously conducted inside of a company, an internal service department, turning those services over to a third-party company simply because it's simply easier to manage costs by not having those costs on our books internally, but rather paying for services only as expenses as they come and as they're needed. It also allows those services to be exposed to the market, in other words, put into the hands of a third-party service provider that can provide the services not just to one company, but to an entire cluster of companies in one region, for example. And that has the benefit of sharing the service knowledge in sort of a pool among a variety of companies that are now customers of a third-party service provider. What do we need for that today, the requirements? Well, we need to understand the machinery, obviously. We need to understand not just the machinery, but also the processes and how everything works. We need to have trust. If I'm giving my services out to a third-party company, I need to confidence that company is going to be around and that company is going to maintain personnel that are always available and that understand my processes. So I have to have local staff and on-site, and I have to have companies that are willing to enter into a contract to bear some of the burden to guarantee performance, like we said before, or uptime. The technical requirements, and this is sort of the newer side of traditional services, is that more and more services are performed remotely. That means that I have to have a secure way of accessing data coming from the machines, coming from the automation equipment, and coming from the processes. I have to ensure security to make sure that I'm not opening up an access point that other people like hackers can get into the equipment or tap into my data. I have to provide an ecosystem and a clean and safe environment for the transfer of data beyond the plant and enter into a sharing relationship with a customer that both parties understand that the technology is in place to protect my data. And with that, I'm going to pass the baton back to Florian for the last bit of our presentation today, which is going to talk about how we're going to merge these different aspects we've talked about today. Florian?
Yes, thank you, David. Again, I think it was already indicated that there is a merge of these two worlds. And I always give the example here of one asset monitoring app that initially was for free. You pay a little bit of a premium to have the opinion and know-how of an expert. And this expert supports you with your setup, have the right visualization, the right analysis all behind it. And then what happens next is you're very happy with your expert. You really think he knows what he or she is doing around compressors. And then you say, you know what, actually if we can have continued service, not just the app itself that visualizes and monitors our compressors, but if you have a supported operation, you have also, let's just meet every once in a month and discuss what's going on. So you educate it a little bit, mixture of training and supported operations. And this is the next step. So in this case, you're going from maybe here you have just a template based, so this may be consumption based, and here already you scale up in scope. So you have the pay-per-use business model, and here you have a much closer collaboration, again, with the company that either supplies the compressor or that supplies the asset analytics for this compressor. And here he or she maybe already gives indication for when maintenance needs to be done, when maintenance should be done, and whatever needs to be to secure the operation. And at the very, very end, you may have the complete outsourcing, and you don't purchase the software anymore, but what you do purchase is you purchase the compressed air or compressed gas, whatever the compressor is doing. Now, if you climb up that value chain, right, here is the part that you actually have a clash or a merge with traditional service business, because this would be maintenance, this would be a maintenance contract maybe of the compressor, and it's now going away because you don't have a maintenance contract anymore, because either the OEM or a third-party app supplier is taking that business away. So this is merging, or this is the merge between software and services. And if you step back here, and this is already something David indicated, ultimately the merge of software and services is an efficiency gain. So what you can do is you leverage the data, you leverage the installed base, you leverage complete fleet, you leverage a remote expert that doesn't have to travel around the world to take a look at the compressor. He just needs to have a look at his monitor. He can be at home, he can be at his own company site. So actually you do increase the efficiency. This is what actually can happen here. And so if the data brings the transparency, and if you leverage that correctly, you have efficiency gains for the owner operator, and you have the efficiency gains for the software provider, service provider, because corrective maintenance is much more expensive than if you can actually plan your employees, if you can plan those in advance. And you have the ability to create better hardware if you close the loop. And there are actually, I think there are much more benefits that you can come up with depending on a very specific application or specific hardware. But these are the mains in our view. In our opinion, those efficiency gains will actually be split between the parties. So if those services are more efficient, they will also be cheaper for the user. So prices of software and services will drop. And this is also a pain for a couple of the automation suppliers. Prices of spare parts will most likely drop, because the emergency where you can get a very high margin on your spare parts, those emergency situations, they will get lesser and lesser and lesser the more predictive and preventive maintenance you have. So this merge, it will cause the market to grow much slower than a couple of the optimists expect, because those efficiency gains again will harm the price, that will increase the competition. But ultimately, again, we think that the market itself over the long run will grow. We expect the growth rates of those enhanced services to be well in the double digits. So one of the few really high growth markets, so you should really be part of that. It should increase efficiency. So the market will grow slower, as expected probably, but it will be really huge potential for everyone who's in there. I said earlier that this market is, or this development is a once in a lifetime change. It's once in a lifetime risk also, as well as a once in a lifetime chance. So in order to bring more transparency again to this market, we are conducting an online survey. So we'll send out, we have sent out actually already a mail. It was linked in the mailing you received originally. So please participate. All participants will receive the key results for free. You will also receive a strategy report on services for free instantly. We are really trying to get more light into this. We want to get your opinion. It already runs for a week. We have quite good participation. So with this, again, thank you very much for your participation here today.
If you want to view or review this ARC web window, just go to YouTube and search for ARC web window, and you'll find this presentation and a variety of presentations from the past few years there as well. They're all very interesting and a lot of fun to look at. Thanks from all of us at ARC. Bye-bye.